two cars are going to crash. The blue car is headed to the east. The red car is going north. They crash in the middle of the intersection, and they're going to move off together at some angle in a particular direction, and we're not sure what that is. Now, we can do this using conservation of momentum, but what we've done previously has been the momentum of 1 plus momentum of 2 equals the momentums of those two afterwards. And that's still true, but now that we're in 2 dimensions, we're going to break down our momentum, our total momentum, in each dimension. So I'll look at the x direction first. And in the x direction, the car that's moving in the x direction or moving east is the blue one. So the total momentum in the x direction is going to be equal to only the blue car's initial momentum, because it's the only thing that's providing left and right momentum, and that would be mass of the blue car times the velocity of the blue car. So when I plug in my numbers, I get 450 kilograms multiplied by 14 meters per second, and the momentum of the blue car is 6,300 kilogram meters per second. Now, going up and down in our y direction, the only vehicle that's providing y momentum before the collision is the red car. So the momentum in the y is equal to the red car's mass times velocity, which is 400 kilogram times 10 meters per second. So the initial total momentum in the y direction is 4,000 kilogram meters per second. Now we know that all the momentum before equals all the momentum after. So when these two cars go off at an angle, the amount of momentum that they have to the east and the amount of momentum that they have up and down has to also be equal. And we can figure out what that momentum is by doing the Pythagorean theorem. Because basically what we have is a momentum in the x, and we have a momentum in the y, and our actual momentum is going to be the hypotenuse of that triangle. So the actual momentum is going to be the square root of my x momentum squared plus my y momentum squared. So that would be 6,300 squared plus, I'm going to go into the blue a little bit here, just out of space, 4,000 kilogram meters per second. We square that, and it's the square root of all that information. And when we do that, we should get a total momentum of 7,462.6 kilogram meters per second. So that tells me the total momentum. In order to figure out the speed, we just have to divide by the masses, because these two cars are moving as one big jumbled mass of metal in that particular direction. So I'm going to go to a next slide, so that way we can finish up the math here. So we just finished by saying that the total momentum was 7,462.6 kilogram meters per second, and we know that the total momentum has to equal mass of the red car times v prime plus the mass of the blue car times v prime. And we can find out what the speed actually is by factoring out the v. So my total momentum equals v prime plus my two masses. Now I can divide them and get my answer. So now I just have to plug in my numbers, and I should have 7,462.6. Decimal point kind of got lost there. meters per second, all divided by the mass of the red car, which was 400, plus the mass of the blue car, which was 450. And that should give me the velocity after the collision. And when I divide that, I get that the velocity is 8.8 meters per second. So that's part of my answer. The next part is we needed the direction. And we can get that from that same triangle that we had drawn on the previous slide. And that would have been the momentum in the x direction and the momentum in the y direction. Total momentum being the hypotenuse of that. And what we're going to be looking for is this angle right here. And we have all three sides of that triangle, so we can use any sides we want. I'll use the p in the x and the p in the y. So I'm going to use the tangent. Tangent of my unknown angle is equal to the opposite side, which is py, over the adjacent side, which is px. To solve for my angle, my question mark angle, I just have to do the inverse tangent of my y momentum, which is 4,000, kilogram meters per second, over my x momentum, which was 6,300 kilogram meters per second. And I get that the angle is 32.4 degrees, and that's above the east axis. So there's my direction, and there's my speed. So after they collide, they'll be going 8.8 meters per second at exactly 32.4 degrees above the east axis.